Electronic configuration or electronic arrangement refers to the number of electrons seen in shells as drawn on a Bohr atom. It can be calculated by looking at the position of the atom on the periodic table. For example, hydrogen is seen as having one proton and therefore one electron, so it has an electronic arrangement of 1. Helium is in the same row or period. It has 2 electrons and has an arrangement of 2. When you come down to the next row or period, we call it the second period, you're now filling up the second level of shell. So lithium here has an atomic number of 3, so it has 3 protons and therefore 3 electrons. They are arranged 2 in the first shell and 1 in the second shell. Beryllium is 2,2, boron 2,3, carbon 2,4, and continuing along the table 2,5, 2,6, 2,7, neon reaches 2,8, and now the second shell is complete. When you go on to the next row, the third period, you have sodium, which has 11 electrons, arranged 2 in the first shell, 8 in the second shell, and 1 in the third shell. Notice the number of valence electrons is equal to the group. So for example, lithium, sodium, potassium are all in group 1, the alkali metals, and have 1 valence electron. Beryllium, magnesium, calcium and so on are in the alkaline earth metals and have 2 outer electrons, whilst fluorine, chlorine and bromine on the right side of the table are the halogens and have 7 outer electrons. We write this, for example, let's take calcium here. Calcium has an atomic number of 20, so it has 20 electrons. It has 1, 2 in the first shell. It has 1, 2, 3, 4, 5, 6, 7, 8 in the second shell. So we write a colon and the number 8. The third shell is also full, 8. And in the fourth shell, it's the second one along, so that gives you 2. 2 plus 8 plus 8 plus 2 gives you the 20 electrons. What happens when this forms an ion? Well, metals lose their valence electrons. So calcium becomes calcium 2 plus, and the arrangement of the ion is now 2, 8, 8, having lost the 2 valence electrons. Similarly with the non-metals, for example chlorine. Chlorine is 2, 8, 7 as its arrangement, 2, 8, 7, adding up to 17 electrons, which is its atomic number. In order to have a full outer shell, it gains another electron, becoming chlorine negative, which is written as 2, 8, 8. Note the ions always have a full outer shell, a full valence shell of electrons, either by losing or gaining electrons. Metals and hydrogen lose electrons, non-metals gain electrons, forming negative anions.